Okay, so let's go try problem 1.33. A kicker punts a football from the very center of the field to the sideline 43 yards downfield. What is the net displacement of the ball? And keeping in mind the football field is 53 yards wide. Okay, so the first thing, let's just go ahead and draw a picture. So let's draw the sideline. So there's one sideline, here's another sideline, and we'll call this right here, this point right here is the midfield. So it kicks it 43 yards downfield at an angle, so it goes out of bounds. So let's just draw like this. So it goes out of bounds right here. So this is one sideline, this is the other sideline. And so we're told that's 43 yards downfield, so we know that from here to here, this right here has to be 43 yards. So we went 43 yards downfield. We're also told that the field is 53 yards wide. So we know that the whole length of the field, from there to there, is 53 yards. So if we're just kicking it from half the field, that means that this distance right here must be 26.5. And so we're asked, what is the net displacement of the ball? So we want to know essentially this line right here. And so you can see it lining up into a Pythagorean theorem problem. And so let's just go ahead and redraw the triangle. So we know this is 26.5. We know that this is 43. And so we can simply just use a squared plus b squared is equal to c squared, where a and b are the two legs of the triangle. So this just becomes 26.5 squared plus 43 squared is equal to c squared. And again, we're calling this c. Okay, so now just to solve for this, we just take the square root of both sides, so we get c is equal to the square root of 26.5 squared plus 43 squared. And then if you plug this into your calculator, it comes out to 51 yards. So this right here is one of our answers. That's the net displacement, so that's the distance from here to here. And now we're also asked to calculate the angle which it kicks it at. So we're asked to calculate this angle right here. So if you remember SOHCAHTOA, right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so this angle is the same thing as this angle over here. So remember, I just redrew it. So we can just go ahead and use tangent, right? We have the opposite angle and we have the adjacent angle. So TOA, tan is equal opposite over adjacent. So the tangent of theta is equal to 26.5, which is the opposite, over the adjacent, which is 43. And then so we just do the inverse tan to solve for theta, because remember we're trying to solve for that. So theta is equal to inverse tan of 26.5 over 43. And if you plug this in your calculator, make sure you're in the right setting, it comes out to 32 degrees. So our solutions for this problem are 51 yards and 32 degrees. And that's it.